Right, let's have a look at this idea of scientific notation and what scientific notation is. So scientific notation, just first of all, is when a number is written like this. I'm just going to write, it's a multiplied by 10 to the power of n. So I'll explain this a little bit, or in a little bit. And then the number a has to be greater than or equal to 1, but a has to be less than 10. So, okay, so what do I mean by all of that? Well, for example, say if I take this number, say the number 3 multiplied by 10 to the power of 4. This is a number that's in scientific notation because it looks like this. It looks like a multiplied by something 10 to the power of n. The a part is 3, and then I've got 10 to the power of n. The n part is 4. And if you look at the conditions for the a part, for this part here, the number at the start, the a part, has to be greater than or equal to 1, which this is, and it has to be less than 10, which 3 is. So this is a number in scientific notation. You can also have a number that looks like this, say 2.1 multiplied by 10 to the power of minus, let's say, 7. So that's a number in scientific notation. It's a, so here's the a part, a multiplied by 10 to the power of, and here's the n part there. And if you look at the a part, well, it's 2.1 is the a part. That's a is greater than or equal to 1, so that's fine, and it's less than 10. So that's another example of a number in scientific notation. And if you notice the n part, it's a minus number, so that's fine. Numbers can, or the n part can be minus as well. So, okay, so how do you put a number in scientific notation? Let's look at a few examples. So say if I have a number like, say 100. Okay, the number 100 in scientific notation would look like this. 100 in scientific notation is 1 multiplied by 10 to the power of 2. So how did I do that? Well, what I did, if you watch, if you think about the number 100, okay, the decimal place would be here. It's 100 is, say, the same as 100.0. So if we look at what we did, I moved the decimal place back 2 places. So it was here, it was there, and I moved it back. I moved it there, and I moved it back to here. So when I put it there, I got 1. So I got 1 point something, or just 1. And then because I moved it back 2 places, that's why I have a 10 to the power of 2 there. So if I take the number, say 1000. So 1000 in scientific notation, well, let's see, where would the decimal place be? So the decimal place, it's 1000, so we got 1000 point, say 0. I can put in 1 at the zeros just to see where it is. I'm going to move the decimal place. I want to get a number that's greater than or equal to 1 but less than 10. So I'm going to move it back 1, 2, 3 places. I'm going to move it back 1, 2, 3 places. So I get 1. So I put it in here. So it's 1 multiplied by 10 to the power of 3 because I moved it back 3 places. So the number 1000 in scientific notation is 1 times 10 to the power of 3. What about a number like, say, I don't know, 4342? So that in scientific notation, we do exactly the same thing. We want a number that's, the first part, the a part, has to be greater than or equal to 1, but it has to be less than 10. So to put this number in scientific notation, our decimal point is here, because it's 4342 point something, so let's put in a 0 just there. So we're going to try and get the a part. It has to be greater than or equal to 1, but less than 10. So let's move it back until we have that number. So we'll move it back once, twice, and if we put the decimal point here, we get 4.342. So the a part is bigger than or equal to 1 but less than 10. So now we have 4.342 multiplied by 10 to the power of, and because I moved it back 3 times, it's by 10 to the power of 3. So how does this, or why are those two numbers the same? Why is 4342 the same as 4.342 by 10 to the power of 3? So the reason it is because 10 to the power of 3, 10 to the power of 3 is 10 by 10 by 10, which is 1000. And if I multiply 4.342 by 1000, I will get 4342. So let's have a look. Let me think. So say if we have the number 571429, and we want to put that in scientific notation. So we're going to change. We want well, we're going to have it as 5 point something. So it's, what is this now? 571,429. So we're going to get 5 point something because it's always going to be a single number, 1 point something, 2 point something, 3 point something, all the way up to 9 point something because it has to be between 1 and 10. So we get 5 point something. So we get 5 0.71429, 71429 multiplied by 10 to the power of, and because at the moment in this number 571,429 the decimal point would be there, but we're after moving the decimal point back 1, 2, 3, 4, 5 places back to here, so we got 5 point something, so it's by 10 to the power of 5. Okay, so that's how we put say big numbers like that into scientific notation. And we can do scientific notation is usually used when you have really big numbers. What about if you've got really small numbers? So say a number like, I don't know, 0.1. So the number 0.1 in scientific notation is going to look like this. It's going to be 1 multiplied by 10 to the power of minus 1. So why is it a minus 1 this time? I'll explain what 10 to the power of minus 1 means in a minute, but first of all, just how to put the number into scientific notation. So if you look this time, look where the decimal point is. So in order to get, we want a number 1 point something, 2 point something, 3 point something, something like that, we have to move the decimal point this time to the right. So we have to move it from here to there. So we get 1 point something. And because we moved it to the right, and we moved it to the right 1 space, it's 10 to the power of minus 1. If you look back at these ones, we were moving the decimal point to the left. So when you move the decimal point to the left, then the n part is positive. If we move it to the right, like we did here, so if we move the decimal point to the right, the n part, this part up here, this is the n part, remember? If I move it to the right, the n part will be negative. So say, okay, let's say 0.003, we'd say 9342. So what's that going to be in scientific notation? So we want a 1 point something, 2 point something, 3 point something. So we're going to end up, when we move the decimal point here, we're going to move it to the right. And because we move it to the right, the number up here, the n part, is going to be negative. So to get a 1 point, 2 point, 3 point something, we're going to move it 3 spaces. We're going to move it from here back to here. We're going to put the decimal point there, so we get 9.342. So 9.342 multiplied by 10 to the power of, and we moved it to the right through 1, 2, 3 spaces, so it's by 10 to the power of minus 3. Let's have a look at one more example. Let me think. So say 7, oh no, let me think. We want a small number, so say 0.000059. Okay, what would that be in scientific notation? So in scientific notation, that would be, we're going to get 5.9 multiplied by 10 to the power of, and we're going to move the decimal point to the right, 1, 2, 3, 4, 5 spaces to get it into here. So it's by, isn't it 5? 1, 2, 3, 4, yep, 5 spaces to the right. So 10 to the power of minus 5 this time. And that's how scientific notation works. Let's say, what about if you have a number in scientific notation? So say if we have the number, let me see. Well, let's take this first number we have up here. So simple one. 1 multiplied by 10 to the power of minus 1. How do we convert that back from scientific notation into not scientific notation? I can't remember what it's called, but not scientific notation. We want to write it back like this. We just do the opposite. So if you go back up here, if you think what we did, we moved the decimal place to the right 1 place. So we had a minus 1 here. So in order to go back, when we have it in scientific notation and it's a minus number, we're going to, the decimal point at the moment is here because 1 is the same as 1.0, but because it's a minus number, to convert it back into not scientific notation, we're going to move it back to the left just 1 place, so we get 0.1. If we have, let's write this number, 9.342, 342 by 10 to the power of minus 3. To take that number out of scientific notation, well, originally we moved the decimal point to the right 3 spaces. So we're going to move it back to the left, because it's a minus number, we're going to move it back to the left 3 spaces. So if I move it back to the left 3 spaces, I'm going to move it, let's put in a few zeros here just so we can see where we're going to put it to. So at the moment it's here, I'm going to go back to the left 3 spaces because it's 10 to the power of minus 3. So 1, 2, 3. I'm going to put it in there. So then I'm going to get 0 point, and if the decimal point is in there, I'll get 009, 0.009, 3, 4, 2, which is what we had up here. It's exactly the same. So they were numbers where we had the negative power. What about if we have a positive power? So say if we have the number, let me see, 5.73 by 10 to the power of, say, 4. 5.73 by 10 to the power of 4. So this time what we're going to do is, if you remember, I'm just going to add 5.73 is the same as 5.730. I can put in as many zeros because it's after the decimal point as I want. So we want this number not in scientific notation. So what we're going to do is we're going to move the decimal point to the right 4 spaces. So 1, 2, 3. So it is here. So I go here, 2, 3, here. So I'm going to put it in here. So then this number here would become 57300. So 57,300 is the same as 5.73 by 10 to the power of 4. Think about how we put it, go backwards. So to put 57,300 into scientific notation, the decimal point is there. We want 1 point something, 2 point something, so we're going to get 5 point something here, 5.73, and we're going to move the decimal place 4 times, 1, 2, 3, 4. So we get 10 to the power of 4. And that's how you do scientific notation. So you're going to have to watch this video a few times just to make sure that you get that and you fully understand it. And then the next part, I'm going to show you how to multiply numbers in scientific notation. So multiplying and dividing, T-I-P-L-Y, multiplying and dividing. I haven't spelled that right, D-I-V-I-D-I-N-G. Okay. So multiplying and dividing in scientific notation. So let's say we want to multiply these numbers. So 3 by 10 to the power of 4 multiplied by, let's say 2 by 10 to the power of 6. It's very simple. So if you're multiplying these two numbers in scientific notation, all we do is we multiply the 3 and the 2 part. So that's going to be 3 multiplied by 2 multiplied by 10 to the power of, and we add the powers. So 6 and 4 is 10. So we have that. And then 3 by 2 is 6, so that's really 6 by 10 to the power of 10. So we add the n part, 6 and 4 is 10, and we multiply the a part, 3 by 2. Let's have a look at another one. So say if we have, say, 5 by 10 to the power of 6 multiplied by 2, now let's say 3 by 10 to the power of minus 4. So it doesn't make any difference if it's a minus 4 and we're multiplying. So we're going to multiply the a part. So 5 by 3 is 15. Multiplied by 10 to the power of, and now we got 6 and minus 4. So we add the powers. So 6 plus minus 4 is 2. So when we multiply these two numbers, we get 15 multiplied by 10 squared. But you've got to be careful here. Remember, in scientific notation, the a part, this part has to be, it has to be between 1 and 10, but it's not. So in order to change it back to being between 1 and 10, I'm going to change that to 1.5 by 10 to the power of, and because I moved the decimal place, remember, 1 place to the right, because it was in here, it's 15.0, I'm going to increase this number 2 by 1, so I get a 3 there. I get a 3 there. So it's 1.5 by 10 to the power of 3. What about dividing then? Dividing is very simple. It's just the opposite. Instead of multiplying these numbers, we divide those numbers and we subtract those powers. So say if I have this one, so say 3 by 10 to the power of 4 all over, I'm going to do a simple one. I'm going to change that to be, say, 6. 6 by 10 to the power of 4 over 3 by 10 to the power of 1. Okay, so all we do is we divide these numbers. So 6 divided by 3, so we have 6 over 3 multiplied by 10 to the power of, and we subtract these numbers, 4 minus 1. So 4 minus 1 is 3. So 6 over 3 is 2. 6 divided by 3 is 2. So that's equal to 2 by 10 to the power of 3. Very simple. What about a slightly harder one where we've got, let me think. So say we did this, 2 by 10 to the power of minus 3 all over 4 by 10 to the power of minus 5, let's say, minus 5. Okay, so we divide these numbers, 2 divided by 4, so we get 2 over 4 by 10 to the power of, and then we subtract these numbers. So we go minus 3, but you got to be careful. It's going to be minus 3, subtract this number, minus minus 5, which will give us plus 5. So that's really 2 over 4, which is a bit of tidying up on this one to do. So we have 0.2 over 4 is the same as 0.5 multiplied by 10 to the power of minus 3 minus minus 5 is minus 3 plus 5, which will give what? Minus 3 plus 5 will give 2. So you have 2 there. But look at this part. The a part here now is not in scientific. It's not between 1 and 10. So we want it to be between 1 and 10. So what do? How do you convert 0.5 to scientific notation? Well, that's going to be the same as, we're going to move the decimal place 1 space to the right. So we get 5 multiplied by 10 to the power of, and when we move it 1 space to the right, what do we do with the power? So what's going to be the power up here when we move it 1 space to the right? So have a look, go back at the start of the video and see if you can figure out what that question mark is there. When we move the decimal place, it is here. We want to move it to there. When we move it 1 space to the right, what happens to that power up there? The answer is in the video if you go back and play it.